GL Sivkumar Babu, so who is a professor at IIT Bangalore. Then followed by Professor Krishna R. Reddy from University of Illinois in Chicago. Then followed by Professor D.N. Singh from IIT Bombay. So myself, Dr. Hanumantha Rao, and my colleague, Dr. Remya and both of us are faculty members at IIT Bhubaneswar in the School of Infrastructure. That's also called as a civil engineering. So I now request Dr. Remya just to formally introduce about the speaker. So this is a brief of, yeah.
So Remya, I can be very brief. First of all, no, doesn't.
First of all, thank you, Professor Singh and Professor Babu, for giving that enlightening insight to the need of our course and what should be done from our side as well as from the participant side as well, for bringing the adopting landfills and how to go ahead in this area. So without much delay, let me introduce the first speaker of the first session of this short-term course. So we have with us Professor GL Sivkumar Babu. Professor Babu is a faculty professor in engineering at Indian Institute of Science, Bangalore. He served as the president of Indian Geotechnical Society during 2017-20 and is the chairman of the International Technical Committee on Forensics, Geotechnical Engineering of International Society for Soil Mechanics and Geotechnical Engineering. He is a fellow of AC and also served as the Governor AC Region 10 during 2014-20. Professor Babu received PhD from IIT Bangalore. He did his master's from Anna University Madras and BE from Sri Venkateswara University Tirupati. He worked as Humboldt Fellow in Germany in 1999-2000, and he is also a visiting scholar in Purdue University, USA. Prior to joining IISc, Dr. Babu worked as civil engineer for 2 years in industry.
Yeah, I think it's long. I think I want to teach graduate class now, if you don't mind. Yeah, it can be okay. Yeah.
Okay. And he also had 3 years of experience as scientific officer in IISc and 4 years as scientist in CRRI.
Yeah, they're all irrelevant now, actually. That's what I meant, those experiences. So it's okay.
Okay. So his teaching and research experience include the risk and reliability applications in geotechnical engineering, geosynthetics and reinforced soil structures, environmental geotechnology, fibers in geotechnical engineering, earthquake geotechnical engineering, geotechnics for disaster mitigation, to list few. He is author for several journal of international repute, and he has published more than 151 full conference papers. He wrote book on soil reinforcement and geosynthetics and edited several books and proceedings. Dr. Babu has supervised 23 research degree dissertations, and he also received several awards of excellence in research and teaching, which include John Booker Award from IACMAG, Humboldt Fellowship in Germany, DST Boycott Fellowship, and few awards for the best purpose from Indian Geotechnical Society and American Society of Civil Engineers. So with this brief introduction about your vast experience, let me ask Professor Babu to take over and give his expert lecture.
Thank you, Dr. Remya, and thank you for a very detailed introduction. First of all, I would like to thank you all for giving me an opportunity and then give a presentation on this very important topic. I will be talking about characterization of municipal solid waste and its role in landfill design. Of course, we don't have any landfills in India, so we have to really, a lot of dumps we have. So we really need to use this knowledge in the rehabilitation of dump sites. In this work, actually, we have been working for quite some time on this. We have the contributions from Sandeep Choksi, then Lakshmikantan, then Dr. Santosh, Dr. Sughosh, and others. I just want to talk about the importance of the topic, then the state of practice, perspectives, and all of that. If you look at the Government of India guidelines.
Sir, yeah? Can I take it? Just a small announcement to all the participants. You can ask questions at the end of this lecture. A 15-minute slot is allocated. Or alternatively, you can also pose your question in the chat box. So either of the options you can exercise. So thank you, sir.
Yeah, so if you look at the composition of the solid waste that is given in the some of the documents, the waste characteristics are completely different when you from India or any other country, like, so compostable matter is about 42% and paper, textiles. We have some numbers that we have and ash and fines and others. You get this number, but actually we are trying to look at the data that we have in Bangalore. So the numbers are similar. Say, for example, you can just say that you have paper, what do you call, the biodegradable waste is in the same range, and even others are there. There could be some variations, and we also know that there could be about 200 300 grams per person per day. This is one number that we need to know for the estimation of landfill capacities. I was just looking at the Government of India statistics, which says that you have a lot of waste generated, and the migration, the way that the people are going to live would be that many people are tending to migrate to cities, and according to Pollution Control Board, more than 1 lakh tons of waste per day is generated, and of course they say about 100 grams per person per day, and the efficiency of the processing is quite low. That's what I see most of the time. And that way, what is supposed to be treated in landfills is actually dumped elsewhere in the cities or villages or even outskirts of the towns and villages. And it leads to quality of life being very poor. And some of these important aspects like, the source segregation at source collection, some of these things are not really okay. And Bangalore generates quite high. In fact, now it is about nearly 6,000 tons per day. And the energy, the collection efficiency is also not great. I mean, I'm seeing the way that they do. And if you look at the municipal solid waste guidelines that Government of India has, it talks about all of these options, like we would like to have source reduction and reuse, which is not really good, like recycling, composting, because we have a lot of organic matter, and we also talk about waste energy plants and all of that, and landfills. So though we say that the landfills are the least preferred, and since now the first two, the source reduction and all of this are not really very good, everything goes to landfills, but then we don't have landfills, we have dump sites. So that is a very sad part of it. Of course, we know that the landfills are very useful because we'd like to store the waste in landfills, and also see that why do do that is that we'd like to minimize the impact of the solid waste because of the mechanism, the thing, like it has a lot of leachate and it has methane generation potential, all of that. So we'd like to isolate the waste through containment, and we'd like to eliminate the pathways of pollution, say for example, air pollution and water pollution. And the landfills also enable the controlled collection and treatment of products of physical, chemical, and biological changes within a dump, both liquids and gases. And why do we do that? Is this, we would like to see that all the environmental processes like, the degradation of waste, leachate generation, they become stable. And whatever you want to treat them and do whatever, it is okay. But at least the whole operation is stable. And it is supposed to be the cheapest way, one of the cheapest ways, definitely, because nowadays at Government of India level, people are talking about so many technologies. When you talk about landfill configurations, of course, this is actually if you have a really start from zero, but unfortunately we don't have those conditions. Maybe in some towns still they can do that. So you have area fill, where the thing is that you try to treat the surface in a proper way and then construct an area fill, or sometimes the area above ground or below ground, something depending on the geological conditions. What happens if the water table is too deep, or it is okay, you can go somewhat deeper, but then if the water table is somewhat high, like say for example 7 or 10 meters, you can't really go to that, and then maybe still, so you can go a bit down and then go up. So this is like above and below. And of course, valley fills, this is what we have in Bangalore. This is a big problem here. Wherever, nowadays a lot of quarry sites are there in some places. They are placing the waste in this down the sites. But then the problem is the technology of doing a landfilling in valley sites is something very, very complicated. It could lead to a lot of problems of leachate treatment and all of that. And trench filling is also there. So there are some options. But then it comes basically based on the geological considerations, the quantity of waste, economics, and so many other things of the politics as well. So, like I was just if you look at a plan, the thing is that the way that we design the landfill would be that suppose you have maybe in Mumbai you have 8,000 tons per day, or Bangalore you have 6,000 tons per day, and we need to have a design of say 15, 20, 30 years or something. The higher is the life, it's better for us because we don't need to worry about where to place them. So you can even put it in the plan view where you can just phase out the waste collection, and initially you need to acquire that complete site and then start with phases where it could be a phase one could last for a few years, 3-4 years, and like that you need to control operations. This is as I was just mentioning, the landfilling is a controlled operation. You need to understand what goes in and what goes out. That is in a way some understanding. But in India, we don't have that. People simply come and dump. They don't have any scientific understanding of the whole thing, including the government units. So, of course, we have a liner system at the bottom, like we always want, because we don't want, this material to be in contact with the native soil. So you try to put a clay liner, and then actually you put a then the geomembrane, a leachate collection system, and all of that you do. And also once I think you have nice lectures on this and design of liners, and you also have covers where once it is completed, you need to have, of course, different types of covers, and like daily cover, intermediate cover, and final cover, and all of that. So you need to look at waste, and then you need to have infiltration layer, and this is a basic thing. But definitely you need to have a geotextiles or any other material, better materials being used. So for example, in the cover material itself, there are so many options that one can think of, like say for example, I think Professor Reddy or even Professor BNS would be talking about some of those things. That how do you reduce the methane gases that are going out of this cover? Because if you see, look at this, even the current guidelines of the government of India, they do not really address these issues of the methane migration and all of that we have seen it. So what is state of practice? I think we should just see what is happening. Actually, this is just one landfill failure. Even if it's constructed, it is somewhere one of the classical landfill failures that happened long back. This is about a liner system where, but this is one of the earliest ones that was investigated very well. All failures are studied very well in landfills, and then they came up with some the guidelines. And I should also tell you in India that its landfill system itself is a flop, total failure, and nobody studied. And only 3 or 4 people like Professor DNS or somebody would be, a few like me, we're trying to work on it. But I think, as I was just mentioning, the kind of disasters that we have in India, that landfill dumping, it is actually a total failure of the system. It needs big forensic engineering itself. So what I just want to say, I've been seeing this out of failures in India. I didn't put those photos, particularly in Bangalore. I'm just trying to put some international photos. This is about dump collapse where many people died. And this is another thing where, in Philippines, about 230 people died. And we have many cases like this. And this is actually what is happening in Bangalore, that, in one of the sites that is close to airport, Bangalore airport. In fact, it's a very sad state of affairs that it's close to airport. They collect this and then put it into trommels and then segregate waste. They try to compost and all of that. The quality of segregation, everything is not really satisfactory. This actually, sometime back, I was giving a lecture to Bangalore engineers, and I was showing them that actually there was a dump failure in Bangalore recently, maybe 2 years back. Actually, you can see that some of the officers are walking around. This is actually Panchanadi dumping site. You can see a lot of methane gas, and it is actually in a green area. See, this is the way it failed, and this is how it looked. So, for example, after extensive rains in August, about just 2 years back, it started sliding. About 9 lakh million tons of waste was there, and it damaged about 9 crores. and it has so many problems. It led to so many issues and all of that. This is supposed to be in a place which is supposed to be very good in engineering, and you can see a lot of green areas around it. And of course in Bangalore, in Delhi, we have this Gajipur dump site. We have of course in Mumbai you have many. I think you can Professor DNS will speak about that. So what are the issues in landfills? I mean, so I think there are a number of issues that we can handle. Identification of landfill sites itself. Like, okay, if you identify a particular site, given that the site is problematic, or okay, what is the way that it can work around? So there are a lot of issues here. One can look at this identification of land, assessment of capacities, because if you want to really it should be cost effective. And then, so assessment of capacity is very important. Estimation of waste characteristics is very important. It's like, you admit a patient in a hospital. Let me tell you, all these landfills result ICUs for all our waste. So you must characterize this waste in a proper way. Okay, then you can understand it properly. So because now since you're trying to have this containment system like liner, cover, and all of that, how well it behaves is a function of the waste characteristics. Then you have a lot of methane gas generated in the landfills, because particularly you have a lot of biodegradable waste to the extent of 50% or something, 40 to 50%. So then how do you do that? Then role of geosynthetic materials is very important, because I have seen a lot of places, you have some 20 acres and they bring soil, virgin soil, and then it is like waste plus soil. They put it becomes waste. I find that the way they do compaction and all is so bad. And the native soil is really used so much. And best is to use some products like geosynthetic materials, which can minimize the natural use of natural materials. Remediation of sites is very important. This is very, very critical in our country, because there are so many sites, landfill sites that are leading to a lot of contamination. I think I can ask somebody to mute.
Participants, please mute your video. Mr. Akhilesh, please mute your microphone and video, please.
Yeah. Okay. So the remediation techniques are quite important, and it's a big subject by itself. One can take another short-term course on that. Then prediction of leachate and contaminant migration. In fact, Madam Dr. Remya is an expert in leachate treatment and all of that. So there is so much of work to be done. Of course, there is a lot of complexities here. Like if you don't do, for example, dump rehabilitation, what is the risk you have? So risk assessment is very important, because there is a leachate contamination with leachate, and then methane migration. Quality of air in the surrounding the dump sites is not okay. So if you want to construct apartments next to them, I think nobody will buy that. So we have seen that problems in Bangalore. So risk assessment is important. Long-term implications are also very important. Of course, seismic stability is one of the byproducts, and many people do it. But the job is good, then it's okay. And the instrumentation, it is very, very critical, because they are so complex. You're talking about the sites, at least for 30 to 40 years, 20 years during filling, another 20, 30 years during in the maintenance. You want a lot of this landfill to be working very well, but it is not easy. So unless you have instrumentation right from the beginning to the end, instrumentation should be built into the whole thing. And unfortunately, it's not done in India. It's a very pathetic state. But what I want to say is that I think as youngsters, you have a lot of opportunities. Just now, Professor Dian was mentioning, adopt a dump site. Please adopt a dump site. We should be like politics should do here, right? Like everybody's adopt a dump site. Let us just create that. Sensitize all the politicians to do. Of course, you should do it, not politicians. Okay, so what are the physical factors that, there are a lot of processes in this municipal solid waste that happen because of biodegradation. We have, physical and mechanical processes like, because it's highly heterogeneous particulate material, there'll be reorientation of particles, movement of fine particles into larger voids, and collapse of void spaces. And chemical processes like, like there is a oxidation and all of that. dissolution processes, because you have all of the chemistry, is happening here. Then biological processes. There are so many processes. There are mechanical processes, chemical processes, then chemical, biological, all of them very complex. And as engineers, we know only, as civil engineers, we know about steel and concrete a bit, but then soil mechanics, we do two subjects. We talk about that, what is that, a three-phase diagram, and people get some marks out of it. Many people don't like geotechnical or soil mechanics. They quit it. They go become structural engineers or whatever, right? Everybody wants to be in infrastructure, but you should understand that this is a big market here. There's a lot of opportunities, and what we are really looking at in landfills is that it's much more complicated. Instead of the air, you have methane here. Okay, who is that? You can ask him to stop. Yeah, okay. So you have instead of the water, you have leachate, and you have biological material. Like, in fact, there is a lot of biosolids, which have a lot of bacteria on the top of the surfaces. So you're handling something very, very complex. What we studied as a three-phase material or continuum is no more valid, and it's a very complicated interactive system of physical, chemical, biological, all of these things. So it's a biogeo interface, people call it. Maybe others will talk about this. When it comes to properties, when you're trying to measure these properties, like what are the things that you need? So you need to go for the physical composition, essentially the composition of the waste itself, and what are the mechanical or hand sorting or whatever it can be done. And you need to find out the moist content and organic content. And there are some basic stuff that we do. So that, say, for example, this basic characterization is also required in trying to adopt what are the methods of recycling options. If you want to have recycling options, if you know the composition characteristics very well, it is possible. Like I have seen in the government of India, they just give some numbers, then the estimates are prepared based on those numbers. But it takes maybe a day to just check, or a few hours to take actually look at composition and then give proper answers. What I find, I've been looking at a lot of the quotations or that work orders and all that. The estimates are prepared without even doing the basic testing, basic composition analysis. That is so bad in the country. So my submission would be that you should alert your colleagues in the environmental engineering departments that they should do the basic characterization of what type of materials it has and what type of recycling options we have. Something has to be decided. Then mechanical properties, why these things are important is that, like particularly I didn't mention here, bulk density, like then shear strength, permeability, and all. The density is very, very important here, because the way that you dump, and in fact, I will show you some results. It should be the government. The rule says that it should be at least 8 ton per meter cube. Okay, actually government of India rules say that it's not easy to get 8 ton per meter cube for solid waste, and of course, unless you have a specialized equipment. And not only that, when you dump it, it is hardly having 100 kg per meter cube. It's not 800 kg. So it's 5 to 6 times less. I have seen it in many places, with the result that what you want, the landfill capacity you want to last for about, say, 10 years, it gets filled up in 3 years or 2 years, and it creates a lot of system stress. And we had in Bangalore a couple of locations, because they don't do it. They start the moment you identify site, people just rush to that and they start dumping, and within 2 years they fill it up, which should have lasted for 10 years. I've been seeing so many sites here. So you need to look at shear strength and permeability, and why is that compressibility, like I'll explain that why, because we are interested in the settlements and all of that. Then when you're trying to look at waste stabilization, because that's another thing that we need, you should look at leachate characteristics. I think Dr. Remya is an expert on that. And because to understand to what extent the leachate can is it a mature or what state of degradation it is, you should be able to do a basic test. Of course, you want to do a lot of detailed tests. And landfill gas, you should be able to measure the methane and CO2. Most of the landfill gas has these two things. So so settlement, these are all there. And then we have to do the biomethane potential test, BMP test. This is some examples that we did some tests and collection, and then we're trying to characterize that material. Like, you can see that 54% is one site I showed you just now. It is called Mavalipura site, site, where it has a lot of problems. So we were trying to characterize that material. I know it has various constraints that we discussed. I'm just trying to give you some sort of engineering analysis that what is happening in Indian context is that you dump the waste, but then it should be properly compacted. As I just mentioned, it should be to good densities. Why is that we want to have good densities is that the life of the landfill gets increased. And if you have organic matter, and then it also settles, because the settlement, if it settles, then there is an extra space that becomes available. So that's important to know. So that extra, so then if we don't know the settlement properly, the capping that you may provide may have problems because it may crack and all of that. So what we do is that we need to know how much of settlement happens so that you can use that additional space and also see that there's no effects on landfill capping. So we have a source approach, which is something very classical, but it is not so much appropriate for Indian or the because this is supposed to be more for some years or other places where the organic content is quite less, and they used it and they may use it for field calibration, all of that. What I just want to propose, we have this. In fact, we had a workshop with Brazil people. Okay, Brazil is doing a very good job when it comes to landfills and other things. So we had one Mark II model, which talks about the settlement is composed of primary compression, then secondary compression, or the creep, we call it, which is actually time-dependent creep and biodegradation. So he was able to clearly understand the three components of settlement and then come out with what should be done, because the practices are different. Whereas in Sower's approach, he clubs both time-dependent compression and biodegradation in one term. Yeah. So these are the respective equations. They are all based on simple geotechnical calculations. The primary compression is known. The creep is a function of the stress acting as well as the rate of settlement. That can be measured both in the lab and the field. And even the biodegradation depends essentially on the biodegradation content and also the rate of biodegradation, all of that. One need to know that. So when it comes to shear strength, see, people have been putting a lot of data like this, stress versus strength. I showed you some photos where the landfill failures have occurred, right? That too, most of the time after the rainfall occurs, right? So in years, they tend to give some sort of generalized picture of shear stress versus normal stress, and then they say that.
Professor Babu, let me just interrupt. Actually, the slides are not moving, sir.
Yeah. Where are we now? Where did you see? Which one?
We can see the table indicating property, characteristics.
Oh, okay.
And parameters.
This one? Is it this one?
Yes.
This one?
Still not changing, sir. Maybe you can unshare and share again.
Okay. Thank you for you should remind that.
Yes.
It's bar also. Now you're able to see the table.
Yes.
Same slide.
Now it is the same slide.
Yeah, same table, right? Yeah. Okay. So this is the way you're able to see the slide now?
Yes, it is changing.
Ask Akhilesh Kumar, he seems to be quite active in the video. It is just disturbing. I think he's putting the video quite on.
Yeah, Akhilesh.
Because he's visible to me than anybody else. Okay. So this is a particle size distribution, and this is settlement analysis I just mentioned. This is what I just mentioned, that the creep and biodegradation is considered in. This is a primary compression. This is a secondary. He combines both of them, but when it comes to actual thing, that when the biodegradation material is more, then you need to use a better approach. This is one. And this one can, there are a lot of papers on this. Shear strength. Are you able to see now movement of the slides?
Yes, sir.
Yes, it is
Okay,
fine.
thank you. So I was just mentioning, so the thing is that we have seen that many of the landfill failures, they do occur, whether it is, both in the, long term, like I saw that there is an geomembrane, so there is a failure. We call it as a drain failure, but after rainfall, it comes. We have so many failures that we saw in India as well as abroad. We call it them as undrained failures in geotechnical terminology. And but then we don't have a proper understanding of this. That's what I want to say. So we did some tests. We call it a consolidated undrained test and drain test. We can see the sample size is quite big, and then the height is 20 centimeters by 10 centimeters. So then we also did creep compression tests and creep tests and all of that tests for not less than 1 year or something. You can see about 1 year tests at various creep. We are trying to find out the properties. So we are trying to get this sustained response also on undrained and drained conditions and all of that. So it's all very interesting. We're able to see good results, but at the same time, we wanted to develop a proper model. What is happening is that looking at C and 5 is all right, but it will not answer because the cohesion friction, we don't know what happens with biodegradation and what happens with time and all of that. If you just only think about C and 5, which conventional geotechnical unit does, because for him that's life. But in municipal solid waste, there are so many other factors that are influencing the shear strength response, stability, and all of that, or settlements, all of that. So we used what is called a modified Kankle model developed, which is fit to account for this, and we are able to get very good, the results on that. We used even the data from Brazil. In fact, we did data from Prof Reddy. In fact, I must thank Prof Reddy because we had some time back, we had discussion on this. Then I started working on this, and we find the model that is very necessary and it's useful. So we're able to do that, and it was able to answer some things like I was just mentioning about, lift thickness. If you lift thickness of 3 meters, this is about a dump. If you have just dumping alone, the problem is the settlements could be large, but whereas the lift thickness of compaction, like say half a meter, 0.5 meters, the settlements could be less. So ultimate settlements, we want to be very, very less in a landfill so that, the material is well compacted. These are all the stress strain responses that we predicted because of primary compression and the creep and all of that. What happens to the strength of the material as a function of the biodegradation? We're able to follow it. What happens due to biodegradation is that the wide spaces get closed. Right? See, what is happening is that there in literature, it's a lot of confusion is there with respect to this concept. But anyhow, these things will be somewhat reasonably you can understand better. So I was just trying to say one more thing was that, say for example, you have a typical dump of 5 meters, dump size, 5 meters is a small fill. We're trying to estimate the primary compression as well as strength. Why it is required is that, the models that we have in they're only one-dimensional models for settlement and shear, whatever. So since the issue is it's all three-dimensional, we need to really look at it, and we did that. So what you can find out factor of safety, how it varies with as a function of number of days, or even the settlements, vertical deformations and horizontal deformations one can compute. And you can even see, this is what I was just mentioning, you have a 5 meter dump or even any dump, you can see after 100 days, there'll be an extra volume. So you can calculate the extra volume, original volume, net volume, new volume, and then volume. So what I was just mentioning was that the volume change that is required, what that you can use gainfully to understand what is happening. Actually, nowadays, our government of India is looking at smart cities, but when I looked at some of these fellows who are working on smart cities, they talk about waste use of even the key. This one of the sectors for the smart, in the smart sector is that apart from energy, healthcare, and water, and it's waste. Unfortunately, there are no understanding of the whole thing, and the way that we want to do that would be that if the landfill can become a smart if its potential in terms of leachate generation, gas generation, contamination potential. So if you're able to do that, it's good. So the leachate generation could be used for recirculation. That we'll see later. I mean, I think Professor DNS will be talking extensively on that. But so the digital technology could be used effectively in the screening of waste constraints, landfill. There are a lot of advantages how digital technologies can be used. Okay, so of course, the bioreactor landfill technology, if we just modify it to suit our own rehabilitation one, so it's okay. So yeah, this is, I think I will not cover on this because Professor DNS will be talking on this. So essentially what we are doing is that we are trying to, the landfill or a dump site is already, you can't do much there. But then if you're trying to add leachate into the landfill in a controlled fashion, so it helps to accelerate or enhance the biostabilization approach. That's what we can do. And the advantage would be that in the case of normal dry zones, dump sites, it's a slow decomposition of waste, inefficient and incomplete decomposition. Overall behavior of the landfill is predictable. As I just mentioned, if you have a lot of measurements, like how much of leachate is being pumped in and what is gas is coming, things become much predictable. So that we want to have. So even we don't know the quality of the life of some of these landfills because they can deteriorate time. So for example, I can give the example of filters. So you design filters in landfills, but I'm sure that they will not work beyond 3-4 years. And we are trying to assure a period of 100 years or 50 years here. So there could be a lot of clogging and other effects. So of course, these bioreactor landfill is being promoted in some sense, but we don't have practical examples. We are trying to work in Bangalore and we have a big project on use of that. And we have taken some 2-3 sites where they called for this approach being used. And we have been working on with some companies where you can monitor the landfill gases, settlements, then put the wells, vertical wells, horizontal wells, and all of that. So this is a typical system that you are going to have in a bioreactor landfill. You have vertical wells, you have horizontal benches, then you have a reactor system, then try to monitor all of that. And this is all well established. I think that we'll be seeing that. So the benefit should be that, yes, definitely the landfill stabilization. In fact, when I took the data that we have for Bangalore, I was telling them that within 3-4 years, you can stabilize this area of, in fact, in Bangalore, we have 300 acres of dump sites. And 300 acres of dump sites, I told them that we can recover in 10 years. With all factoring in all the processes. And 300 acres in a prime area in Bangalore is quite expensive. So I was just mentioning that you can remediate these sites. That's what I was just mentioning. Yeah, we did say why the confidence was that, we did some different types of reactors in the lab. Like we test, as you just mentioned, we did tests like biomethane potential tests, the total voltage salt test, CHM analysis, and all of that. All of that we did, and we started with simple cells, trying to understand what happens, and we are trying to understand the compressibility behavior and gas generation potential. So this is something that we say that the initial MSW to take compressed as it is or dry, supposed to be in a landfill, normal landfill, or in a bioreactor landfill, what happens? So we're trying to measure or estimate the compression properties and all of that. Okay, so even the gas, this is another interesting result that we are able to measure for 1 year, just to understand, because to convince others, particularly in the local people, they have a way of telling that, oh, you did for Mumbai, but why Bangalore? I don't know. These are all simple, cynical attitude. So I was trying to show them some results, which will tell you, like, you can see that the for gas generation is quite good if you, in a bioreactor landfill. And even the settlements are quite faster. So for example, in a small landfill, it's a small experiment setup. We have 20 liters of gas as against 5 liters in the dry conditions. Even the CHN analysis was given, and you can see that the carbon, it comes down much lower. And so some of these conclusions from this could be that you can have some this concept of bioreactor landfill is quite good for Bangalore. And we also did large scale tests because 60 kgs of waste was done and it's something that we did because this is another site that we did. where we're trying to monitor everything and the leachate and even looking at leachate treatment, all that we are doing. So that is done long back. When Dr. Lakshmikant now, he's a scientist from Neri. He's actually not in his background. He did extensive work on this. Now he's actually working a lot on this, which is very good. So these are some temperature variations. Of course, we are now trying to measure in the dump sites. Maybe because otherwise the COVID has affected, all the money has, we have, they have sanctioned a lot of money for this. I could manage to talk to the government and then they could release the government money. But now COVID has put a lot of things in the back burner. And still, I hope now in the coming months we are able to start this work. Because we have already identified the sites in 2 sites, and we are going to, we have designed everything. So field installation has been done. So in fact, the leachate analysis, much more detailed analysis was done. I will just show some results. So this is again a bigger cell. See what happens, most of them, you'd start in a small limited way to understand, but you try to increase. Now we are trying to do a field scale level, or even simulations and all of that. We have been working on it. Quite interesting results we have. But the only thing is that, as we just discussed, these technologies need to be used in the Indian practical site conditions. Initially you need some understanding. That's where the properties of all of this are required, because you need some sort of calibration and updating information in the field. Just I wanted to say some more information. Like this is another site that I will talk about. There are a number of sites. This is one other site that I took for remediation. It's about 20 acres, and it was processing a lot of waste, and there was nearby water bodies. Then led to a lot of contamination and other issues. It is actually electronic cities, everybody knows in Bangalore, but it has a threat from this site. In fact, you can see the distance, you can see that electronic city, there's a dump site. It is actually close to National Park also. We have a Banerghatta National Park. There should be a picnic spot. So they were trying to cover this waste. Then I had to intervene, and their plan was that they're trying to construct houses for urban poor. I told them that you cannot have houses for the urban poor on this, because the challenges, the water is contaminated and the soil is, methane. So this is, you can see the leachate. Okay. So you can see, it's all dumped very indiscriminately. One thing, they started as a scientific landfill, but they never bothered about putting a leachate collection. There was no design, there was no documentation. This is a very sad part. So that was a challenge that we had. But ultimately it became a dump site. So you can see that the methane, a lot of methane next to the same site. So as I just mentioned, we use this data to develop rehabilitation measures. I was just mentioning that, I try to characterize this waste, like, again, it was quite challenging. Unfortunately, we don't have sampling methods of waste, and, the technology is very poor. The geotechnical investigations themselves are very poor in the country. And how do you expect them to do very well here? So the fellow, I had to appoint somebody to do this, and he had a very tough time. And at 2 meters level itself, in this 26 meters deep for each side, the leachate was at 2 meters or 3 meters level. You have measured all the organics. You can see that there is a degradation, about 40%. There is some 30 to 40% that is organic content. And so leachate characteristics are there, So then there was government has approved for rehabilitation of the site. Some funds are allotted, but as usual, I was trying to see if any technology is available, any people they can do this. And it was very difficult to convince the people to undertake this work, because it's a risky thing. So that was one thing that I had. So we designed a leachate collector. The thing is that leachate treatment system, gas venting system, slurry walls, because it's contaminating the nearby water body, and all of that we did. So this is the way it is, and about slurry wall, about 26 meters depth and all of that we did. What I just want to highlight would be that I just want to conclude with, because I want to give some time for discussion as well, and I'm very happy that Professor Krishna Reddy joined. So as I just mentioned, we started working long back, and it, he has been very motivating for many people in India. So I think definitely like we have to, as responsibilities as waste generators, we have a lot of things to do. It's like particularly the engineering community, we need to really force our local bodies and the government to look at this polluter pays principle and try to understand all of these implications of reduce, reuse, recycle, and all of that. And landfills, they are not, of course, in some towns now, people are looking at landfills. But then if in the towns also, like, the problem is that landfill is a technology, and for a population of 5 lakh or 10 lakh, I don't know whether it is worth. So one needs to really plan well and then do well because it's not easy. Maybe for bigger cities, it may be all right. So we need to, they have to, and then that's where we can contribute, like if you have these options of recycling, reusing, and all of that are much better. And then we should, wherever there are contaminations and all of that, there are a lot of technologies that we have in Indian context. So of course, considerable support for research and design is required, because what is happening, the government of India has produced a document, solid waste guidelines, but there is no clarity on how do you proceed with the design, or what are the types of problems. There is not much information. It's left to the imagination of some of us or all of us. So there is a lot of scope for research, teaching, short-term courses, and all of that. And rather than the ad hoc approaches, I always give a small example that you want to construct a house in a site like 40 to 50 meters, 50 by 50 feet site. You take a lot of care in doing a construction there, and design and construction. But there are some hundreds of acres lying like this. There's so much of pollution. We are not really being the right approach. And the design is not rigorous, analysis is not rigorous. This is where we have to focus on this. So I just this is what I would like to say. So we have, as I just mentioned, a lot of challenges we have in landfill management. And I just mentioned about property characterization, whether it is for MSW or gases or even leachate to some extent. There are a lot of things that I think we have experts to talk about it. And so this is a multidisciplinary area. I think there are very good articles on this. And I know a lot of contributions have been there on this, how different disciplines can address this and then come out with nice options. And there are a lot of opportunities for all of us to come to see that we have good practice of waste management. So thank you very much. Thank you, sir. Thank you, Hanumantha.
Yeah, thank you, sir. So I now request all the participants, we can have 1 or 2 quick questions to Professor Babu. Please unmute yourself and pose a question.
So they have to come out of their mobile and browsing their mobiles.
Yes, yes.
So now I think the next lecture it's 10:30 or 10:40. What time is that?
Yeah, time. So 10:40 minutes.
Yeah.
Hello, sir.
Yeah, tell me.
Sir, can I take a question directly, sir?
Yeah. Please tell me.
Sir, actually, I am doing some study in this landfill liner. So
okay.
I have seen that means with different dielectric constant pore fluids, I am seeing the permeability.
Okay.
I'm using in different pore fluids to check the permeability, and I have seen that with higher dielectric constant pore fluids, the permeability is less. As the dielectric constant goes down, the permeability is also increasing.
Okay.
But again, for like 100% bentonite, which is the ideal case when void ratio will be maximum. Okay. Now, if we consider only 100% bentonite.
Yeah. So let me answer. I know I understood what you want. See, my submission would be that these are all the work that people have done long back on variation of dielectric constant, how it affects permeability. It's very nice for a laboratory study. Okay. But then I think, in my opinion, I think you must be able to relate it to the field behavior. How do you want to relate it? Is possibly you need to check how do you do that. This variation of the electrical conductivities or the best properties, they're all well studied. I think you're also doing it. It's a good thing. So your question is on why the permeability. What is the exact question you have in this?
Sir, my question is exactly like that. In my study also, in literature review also, I have seen that with higher dielectric constant, the permeability is higher.
Yeah.
Permeability is lesser. As the dielectric constant goes down, the permeability also increases. But the void ratio for 100% bentonite is more.
Yeah, one thing my suggestion would be, we'll discuss separately. This is a minor thing. Okay, I want you to address. I'll be happy to take content. We can discuss. My email is there. We'll discuss elaborately. We'll give chance to others. Okay, I understood your question. Yeah. Any other questions? Some more questions. I think somebody, I saw a very nice chat box.
Yes, sir.
Because sometimes what happens is.
Excuse me.
Yeah, tell me.
Professor Babu.
Yeah.
Good morning. Thank you. Myself, A.R. Dasgupta.
Okay,
Actually, I am really delighted to listen to your presentation, but I have got one small question. See, when I am finding, say, in Sweden particularly, and you might be knowing better than me, in Sweden and some of the European countries where they have banned the use of landfill for MSW. So I just wanted to know what's your thinking about a country like us, because here, as we have rightly told, right from the start point, we don't segregate the waste properly. We don't think about the calorific part. So if we don't think about the calorific part, then we cannot think about the waste to energy.
Right.
So those options are there. And as you know, then in India, land is a big thing, not only for, getting the land, but it's a political issue also. So considering all those aspects, is landfill going to be a good solution for India in the years to come? Thank you.
See, let me tell you. See, the thing is that you cannot avoid the landfills, but you must be able to have these practices of all we discussed, that segregation and recycling and reuse, all of that. Minimum should go to the whatever should go to the landfill should be minimum. And then it should be a more a containment system, and it should be very, very safe. I don't know if you take a policy decision that I don't want to ban landfills and all. I don't think it's correct. Definitely, because we have a long way to go. Like maybe people in Sweden and other places, they have achieved a level of, they are most of the time going for waste energy plants that I know. Because they are coming quite often to India with a lot of proposals. They want to burn all our waste, and they want some 100 crores of money and then some few acres of sites. And I have seen it. But I think in the Indian scenario that I still, it may be cost landfills, proper recycling and all could be more cost effective. Like you have biomethanation plants, all of that, without understanding and doing a basic, I have not seen a basic analysis. That's the biggest problem. Like, we know the type of waste and try to come out with, per ton of waste, what is the expenditure involved, or 100,000 tons or whatever. There is no scientific analysis for any city or for a town. That is where suddenly because of political connections with waste energy plants will come, and we have a problem. I think waste energy, none of them have succeeded in India. Actually, that is experience has been quite poor. So that's one thing I would like to say. Yeah.
Okay, thank you.
Yeah. So some more questions. Anything questions?
There was one question on stability analysis of municipal soil waste.
Yeah, I see. Sweden. Yeah, how to ensure? Okay. See, how to ensure the stability of MSW from time to time. The stability in the sense, that we do regularly. We have to see, the way it is dumping is done. We need to initially do and regularly check, like the way you do for any of the structures that we do. Regular maintenance and regular thing is required. It should be done. And of course, unfortunately, we don't do it in India. Maybe for Gajipur landfill or some landfills they do it. Then there is a question on sampling techniques. I think this is a big problem in India. I think Professor Manoj Datta and others have been conducting a lot of workshop on this, but I think it is also, we should have proper introduction here, and then a good company should be able to do it. All the sampling, the MSW sampling, and of course, leachate collection, other things are okay. I find that in samples, how do you take samples? That's a problem. Yeah. Any more questions? Yeah, we have 3, 4, 5 days to go ahead. I think Professor Reddy is there.
Yeah.
BMS, they will answer all questions, no problem.
You are also there, sir.
Yeah.
Yeah.
I'm ready to answer.
So thank you. I once again thank you. Thank you so much, sir, for accepting our kind offer and delivering your expert lecture in this short-term course. So
yeah, thank you.
sir.
So shall I unshare?
Yeah, please unshare, sir.
Yeah, I think I unshared.